Now students, see question number 3. Okay, that is ISRO 2018. So this question number 3, set C. So here given that an antenna is fed with 200 pi watt. See here, input power given to an antenna is how much? P input power is given as how much? 200 pi watt. This is my input power that is given to the antenna. So the efficiency of antenna is given as 75%. How much? 75% efficiency is given. The radiation pattern of an antenna, radiation pattern is given as theta phi is equal to how much? So that is given as sine square theta into sine square phi, sine square theta, sine square phi, where theta and phi both are lies in between. Theta and phi both are lying in between 0 to pi. Okay, both are in between 0 to pi, and asking what? Otherwise, okay, otherwise it is 0. Okay, and he is asking find the radiation intensity in the direction of maximum radiation. Radiation intensity in the direction of maximum radiation. Okay, so in the direction of maximum radiation, radiation intensity in the direction of maximum radiation. First of all, radiation intensity is what? As we know very well, radiation intensity U. Okay, so U is given as what? P radiation. Okay, radiation by solid angle. What? P radiation by solid angle. Okay, so this is my P radiation by solid angle. So let us see P radiation by P average. You can write also P average. Okay, so this is, let us say this is what? My solid angle. So now P radiation is how much? As we know the relation between, see, efficiency is equal to P radiation divided by P in. So this P radiation is how much? P radiation is equal to eta into P input power. Okay, so P radiation is equal to how much? That efficiency is given as 0.75. okay, into P input power is 200 what? Pi. So this means 150. So this means P radiation is equal to how much? P radiation is equal to 150 pi. Okay, watt per meter square. Okay, so this is my P radiation. Okay, so now we have calculated P radiation. So let us see next what? Next about solid angle. Okay, so solid angle, so which is nothing but given as surface integral. Okay, surface integral, this is radiation intensity. Okay, so radiation intensity, the radiation pattern. Okay, so this is what? Solid angle. Radiation pattern of an antenna is given as P theta phi into D. Okay, differential solid angle D psi. So now see here, solid angle, that is nothing but equal to surface integral. This is about phi, theta, both are from 0 to pi given. Okay, it is given as 0 to pi. How much it is given? That is sine square theta into sine square what? Phi into D. Differential solid angle is nothing but how much? Sine theta d phi. Okay, so this is my solid angle. Now we have to solve this. Okay, we have to solve this. So let us see. So this is, let us solve here what? Solid angle. Okay, so this is 0 to pi. Okay, so now this is what? Sine cube theta sine square phi d theta d phi. Now either you use here general formula, otherwise you apply here Wallis formula. So better to apply here Wallis formula. What formula? Wallis formula. Okay, what is that? Let us see. This is solid angle 0 to pi. Okay, sine cube theta d theta 0 to pi sine square theta sine square phi d phi. How we can apply Wallis formula? That is, as we know very well, just multiply by 2, divide by 2. So multiply by 2, divide by 2, because Wallis limit is 0 to pi by 2. So this is sine q theta d theta. Okay, so this is then 0 to, now here also same, multiply with 2, divide this limit by 2. Okay, so it is in Wallis form. So sine square phi d phi, because Wallis limit is always from 0 to pi by 2. So to balance that, we have taken here 2 and here divided by 2, means we are balancing. Okay, so now it is in Wallis form. So now we can apply here Wallis formula. What is that? See here. So psi a is equal to, Wallis formula is nothing but, this is 2. Okay, so this is 2 into just you see, this is q. Okay, q. Then if it is odd power, okay, odd power, what you do? 3 minus 1, 3 minus 1, 3 minus 3 in odd up to 1. 3 minus 1, it is terminating here only. 3 minus 1 is how much? 2 divided by 3. Okay, divided by 3. 3 minus, like it is what? Odd power. Okay, so it will come 3 minus 1, 3 minus, means if it is n, suppose if it is n, that n is odd, so you can do n minus 1, n minus 3, n minus 5 on numerator, divided by in denominator n, then n minus 2, then n minus 4, n minus 6 in denominator. Okay, then multiply that with 1 with if n is odd. If n is even, then multiply that with pi by 2. Okay, so let just do this. Okay, I will give you at the end this explanation. Okay, so now this is 2 into 2 by 3. So now for this similarly for this, see here, power is 2. Now we have to multiply it with pi by 2. Okay, so this is 2 into, what is 2? So 2 n is 2, so 2 minus 1 divided by 2. So this is 1 by 2. So here power is what? Even. So multiply this with pi by 2. So 2 get cancelled. Okay, so this is how much? Solid angle we got how much? 2 to 4 by 3 into pi by 2 2 to the 4. So we got solid angle as how much? Solid angle is equal to 2 pi by 3. Okay, so this we got. So now let us put this into final answer, then we will get what? Radiation intensity in maximum which direction? Maximum radiation, direction of maximum radiation. Okay, so this is radiation intensity, what? P radiation divided by what? Solid angle. Okay, so P radiation, how much we got? P radiation 150 pi. How much we got? Solid angle 2 pi by what? 3 or not? So this is what? 450 what? Pi divided by 2 pi. So this is how much? Radiation intensity is nothing but, this is 225 watt per steradian. Okay, so this is the answer. Okay, so answer is here, answer is A, option A is correct. Okay, so Wallis formula is nothing but, let us see here Wallis formula. What is this? So this is what? 0 to pi by 2. This is what? Sine what? N cos to the power m. Okay, so d sin theta. Okay, so sin theta d theta. So this is nm. Okay, so it is equal to what? n minus 1, n minus 3, n minus 5, like this in odd order. Okay, into similarly m up to 1, then similarly m minus 1, okay, m minus 3, m minus 5, and so on up to 1. Okay, divided by then what? N plus, if it is multiply, if it is in what? Sine and cos form, so n plus m minus 2, like n plus m minus 4, n plus m minus 6, and so on, like this up to this. If both values are even, then you multiply by pi by 2. Okay, if both are not even, then just multiply with 1. So this is for sine and cos combination, both. Now if it is single only, like this, sine, either sine or cos, so see here sine and theta d theta. So for this, what? N minus 1, n minus 3, n minus 5, and so on up to 1, divided by n into n minus 2, n minus 4, n minus 6, and so on up to 1. Then after that multiply it with, if n is even, then multiply it with 5 by 2. Okay, if n is odd, then multiply it with 1. So this is all about Wallis formula. Okay, so that's all. So now, okay, if cos will come, if you are thinking that if cos to the power n theta, then what you do, just, so for this also same. Okay, cos and same, it is valid for both. It is valid for both. Pi by 2 sine and theta d theta equal to this cos theta d theta. So this is valid for both. Okay, so this is all.